Okay, let us introduce ourselves first. My name is Eng Yi-en and my metric number is 205-828.
My name is Eng Jami, metric number 206504.
My name is Noraini binti Mustafa. My matrix number is 20669.
My name is Nafagira binti Ahmad Kamal and my matrix number is 205275.
My name is Nurhaniza binti Mursid and my matrix is 205477.
Okay, this is all our group members. Before this, we have done the group exercise together with the link that shared by someone, right? So now arise the discussion. Some of us will wonder why is it that question will have those answers. So let us discuss. If you have any question or what confused, feel free to point out. We discuss together. Okay, can you see the slide?
Yes.
Okay, let's
Yes.
go for the question number 1 first. The question number 1 state that give the transcript sequence. Okay, this is the answer that given by some among us, right? So, does anyone would like to ask why the answer is like this?
I want to ask why in this transcript sequence we don't change the nucleotide G and C in that sequence.
Can you repeat the question?
Okay. I want to ask why in this transcript sequence we don't change the nucleotide G and C in that sequence.
If based on my okay, can someone answer?
I would like to try to answer. I think
Okay.
it is based on what I know. The sequence given in the exercise is in 5 to 3 direction. But when it is transcript, the RNA polymerase is from 5 to 3, so the template should be 3 to 5 direction. But in this exercise, it is from 5 to 3 direction. I think you can see the figure below. This is the example. We use template strand to transcribe, not the non-template strand. So when transcribe the template strand, the strands produced is complementary to the non-template strand. Do you understand?
Yes. I understand.
After
I want
that,
to.
Hmm?
Oh, sorry.
It's okay.
I want to ask question. Why
Mm.
we need to start from +1 and not from the beginning? ATGC.
I will try to answer. Is based on my understanding, the transcript is referred to the product of the transcriptional unit, which is mRNA, right? So mRNA, we will start from the start. +1 +1 is the initiator element. So the RNA polymerase 2 will start to polymerize the mRNA strand start from the +1. So it will produce the sequence that shown on the screen like AUG and until the stop codon. Is it clear for you?
Yes. Thank you.
Okay. Does anyone still confused about the answer that's set at here?
I want to add on some information.
Okay.
Actually, RNA polymerase is bind to the promoter site and bind to data box, but it only can escape the promoter site when the nucleotide is more than 10. Once it is escaped from polymerase, it will start to transcribe, which is start from the transcription start site at +1. So I also think that the transcription sequence is start from +1.
Do I need want to add something? I also agree with Xiaoming to like want to start the transcription. We need to like promoter escape from the promoter site. So the RNA polymerase can further polymerize the template to produce the transcript. Does anyone want to add something?
I think we can proceed to question number 2.
Okay, so let us proceed. The question number 2 state asks which is the core promoter. Okay, so if based on my understanding, the core promoter is referred to the data box and the initiator element, right?
Yes.
And then the data box also just the distance from the distance right near to the initiator start element like -30 to -35. Is it correct?
I think it's around that number because we cannot confirm that the promoter is at a specific region. We only give some range which is -25 to -30. But this is in eukaryotic. In prokaryotic, that is different matter lah. Anita, do you want to add something?
I want to ask, how do we determine the initiator element length? Do you guys hear me?
Yes, we can hear you.
Okay.
The length, I think, based on my understanding, the initiator element can be found around the range between transcription start is around +1 day. But for the range length, I'm not really sure.
Oh, okay. Thank you.
Me too, not really sure the length of the initiator. Based on my understanding, the initiator element is between the transcription upstream of transcription start site and downstream of the transcription start site, which the transcription start site start at the initiator element like the adenine, like because the percentage of the adenine found is higher, like 50% like this. So the initiator element will be between the transcription start site, but the actual length we are not sure. Hagira, do you want to add something?
I just want to ask about the 5 prime to 3 prime. How can the GCTATGG just stop there? How it just stop there? It just I can understand the sequence.
Okay, yes.
Oh, I think I can explain that because I'm the one who write it. I only list out the sequence between promoter to initiator. From data box to initiator element. This is the That is the range for co-promoter. Because it is TATAAT, which is data box. After that, for the initiator element is around the transcription start site. So I wrote until TTG. Okay.
Okay, okay. I understand now.
If I see something in this answer, uh, for the initiator element, just now I said that if the initiator element is between the transcription start site, right? Then here the A refer to the plus one. Then if this if all of this is the initiator element, so that means the initiator element is like got upstream and downstream from the transcription start site. Mm.
True. I quite agree with you.
Aini, do you want to add something?
I think I agree with you all because for the co-promoter, we need to determine it from the data box to the initiator promoter, right?
Mm.
Initiator side.
Initiator element.
Mm.
I would like to add that coding sequence is involve DNA sequence and RNA sequence. And then if you can see the questions number 4, the both DNA and RNA will start at start codon and then stop at the stop codon TAA. Okay, that's all from me.
Everyone agree?
Yes, I think we can proceed to question number 3 is no question.
Okay. The question number 3 is write the template sequence for the transcription. Actually, I quite confused. The template sequence is refer for the all the template strand or just the sequence that need to be transcribed.
I think that for me, transcript template strength is not equal to the region where it go for transcription. So template strength, template sequence is start from the transcription start site. Because template sequence is not equal to the region where transcription start. So it shouldn't be start from start codon. So I think it is start from the transcription start site.
Oh, that means the template sequence is just start from the transcription start side. If the question need us to state the template strand, then we just write down the question, right?
Yes, it's not mistaken because template strength is not equal to the codon for it's not equal to the region for transcription to start. And then the template strength is in 3' to 5' direction because the RNA polymerase will transfer from 5' to 3'. So the template sequence is complementary to the sequence shown above the exercise.
Okay, that's clear for me. Thank you. Fakira, do you want to add something?
No, but I agree with Jamie's answer. I also have the same thought.
Okay. How about Haniza and Aini?
I agree with Jamin because I have the same opinion with that question.
Okay.
I also agree with Jamin.
Okay, so should we proceed next question?
Yes.
Okay, so we go to the question number 4. Write the coding sequence.
Can I know why the DNA will start with 5 prime to 3 prime and not 3 prime to 5 prime?
Oh, I'm the one who write it. The DNA which is from 5 prime to 3 prime is not the template strand. It is the non-template strand. Because if we refer to the figure above, the primary RNA transcript is totally same as the non-template strand, but only that T thymine change to U ratio. The template strand should the template strand is used for transcription, and the product produced is complementary to the template strand. But the non-template strand and primary RNA transcript is also complementary to the template strand. To make it easier, I list out the non-template strand which is complementary to the template strand. So from the non-template strand, we only need to change the thymine to U ratio, then we can get the RNA sequence. This is my way to get the answer because I think that it is quite easier compared to we list out the template strands and then for the template strands we transcribe it. So in the question, I write the DNA in 5 prime to 3 prime direction first, then RNA 5 prime to 3 prime. So I can, based on the DNA, which is non-template strand sequence, I can directly write out the RNA sequence. For example, A, then I write A. T, I will change to U. So it is quite simple for me to list out the sequence. Okay?
Okay. So we the coding sequence we start codon and end with the stop codon.
Yes. The I want to add something for the DNA. Based on the figure show is a non-template, right? And the underlying one is the start codon, which is the ATG. So for the template stand is actually the T. This is the can you see? This is a non-template stand, which the underlying one is the start codon. And its complementary sequence for the template strand is TAC. If TAC is being transcribed, it will produce the AUG, right? So AUG is actually code for the methionine, and the methionine is the start codon. And methionine is the first amino acid for the polypeptide. Is it correct?
Correct. AUG is not only for start codon, it is also code for methionine. But if methionine is not used, the methionine will be removed. So not every polypeptide produced is start from methionine. Depends, some will start from methionine, but some will not. If methionine is not needed, then methionine will be removed.
I agree with that. Do anyone want to add something or extra information that can add into? And same goes to the stop codon. The stop codon here is ATT, right? So the template strand is A For the non-template is TAA, for the template is ATT. So after being transcript, will become the U, U, U what U,
UAA.
UAA. So UAA is a stop codon.
I want to ask, is it UAA is the only stop codon? Is there any other stop codon or only one stop codon? Haniza or anyone want to try to answer?
Okay, I will try to answer. Based on my understanding, got other stop codon, which is UAG and UAA and UGA.
Then my next question is that the stop codon same as start codon? Because just now you mentioned that start codon also code for methionine. So does stop codon also code for any other amino acid? Anyone can try to answer.
Annie, do you want to answer? Haniza? Akira?
Jamin, can you repeat the question? I quite confused.
Okay, I can repeat. Just now you mentioned that the stop codon, other than it is used for start the transcription, the stop codon AUG also code for methionine. So my question is, does the stop codon also code for any other amino acid?
I think there's no amino acid for stop codon. But I'm not sure with my answer. Sorry.
I also I'm not sure, but I also think that there's no amino acid will be encoded from the stop codon.
For my understanding and learning, for the stop codon, it will not code for any amino acid. That's all for me.
Okay, thank you.
Okay, can we proceed to the last question?
Yes.
Okay, the last question that is state the length of the coding region, transcript, and call promoter. For the length of the coding region here, we see someone write 2303 minus 2300, which is 2303. 2303,
2303 or 2300.
oh sorry, through
2303 minus 230. Anyone want to try to explain why it is start from 2303 then minus 230?
Can I try?
Oh, sure.
Okay. It start from 2303 because you can see that TAA is the stop codon, so it include A at the end. So that's why it's 2303. And then you have to minus with 230, that is the start codon. So that's how we get the coding region length. Okay, that's all.
I have one question.
Do you
Is it the positive?
agree?
Okay. Yes, yes, I agree with you. But I have one question for the 2300. Is it for the T or for the G?
It's T. 230 for
It's
T.
T.
Yeah.
So actually I'm quite confused between the coding sequence and coding region. Can someone explain?
I can try to explain. Based on my
Mm.
understanding, coding sequence is not equal to coding region. The coding sequence is the sequence of the gene, but the coding region is the region where it is being transcribed. For so coding region, there will be a start from the start codon until the stop codon, and that's the region where it is transcribed, then translate to produce polypeptide.
Now I have one question. If the coding sequence is referred to the sequence of the DNA, then the coding sequence will also from the what right from the start codon, right? I'm quite confused. I'm still quite confused why we don't write the downstream from the transcription start side.
You mean for coding sequence?
Yes.
Mm, I think I need some time to think about it. I think I will give you the answer. I will try to give you what I understand later.
Okay, thank you. So we go. Does anyone want to ask why the length of the coding region is like this?
Uh, I think
Or every,
I think we made a mistake because you mentioned that T is positive 2300. Then TAA, the second A is 2302. If like this, I think the length of coding region should be 2302 minus 230.
but I think
Am I correct?
the positive is stayed above the G, right? So I think the 2300 is for G and plus 3 for
It's
the
for G.
next 3.
Oh,
Uh, yes.
oh, okay, thank you.
Okay. Is it okay for everyone? Haniza, Hagira, and Aini, okay?
Yes, okay.
Yes.
So we move on the next question. The length of transcript. Mm.
Oh,
I think I found an answer for your question just now. Sorry. For
Okay.
coding sequence is the region of DNA or RNA where the sequence is determine the sequence of amino acid in protein. So that means the coding is sequence is used to determine the sequence of amino acid in a protein. To produce polypeptide, it is start from the start codon. So that's why
Mm.
in the discussion, in the exercise, we wrote from the start codon until stop codon.
Oh,
Because
so
that's the
this,
reason code for. Huh?
oh, yes, yes, yes. Okay, you continue.
So that's the reason where it is code for protein.
Okay, I understand. Thank you, thank you.
Okay.
So for the coding, so that means the coding sequence is necessary code for amino acid. If necessary code for amino acid, that means we need to start from a start codon. Is it like this?
I think yes.
Oh yeah, I also agree. I think yes.
Okay. Should we proceed the next question?
Yes.
Yes.
Okay. The next question is the length of the transcript. Can someone explain why the transcript is 2500? And one
Um,
can explain?
I want to ask why we need
Mm,
to take the length of the script from upstream and to the downstream.
can you paraphrase your question again?
I want to ask why
Mm,
we need to take the length of the transcript from the upstream to
mm.
the downstream of the string.
From the upstream, I think at here the 2500 is refer from the start codon to 2500, which is the downstream from the transcript, from the start codon. It's not, I think it's not, which is the downstream from the start codon. I think it's not from the upstream. Based on my understanding, can someone clarify again?
If
Mm, for, oh,
2500 is the downstream length.
I think yes, the 2500 is for downstream. Am I right or got something mistake?
based
I think
on. Oh,
you're
okay.
right. I think CN is right. It is from the downstream. Yes, Jamie, you can continue. Sorry for interrupt.
Actually, I quite confused. What do you mean from downstream?
Mm, just now who asked the question Haniza, right?
Can you repeat the question because I quite blur.
What I mean is that 20250 is from the beginning of the sequence to the end of the sequence. Not for start codon to stop codon.
Oh, I know what you mean. So you think that 2500 is not the correct answer?
No, I mean the sequence is from the beginning of sequence to the end for
Oh, okay. I know what
2500.
you mean. Okay, so you mean that the length of transcript is start from +1 until +2500. Is it true? Okay.
Is it everyone okay? Annie,
Yes.
do you want to add? Haniza, do you want to add something?
No, no.
Just now, Is it clear for your question for just now?
Yes. Thank you. With that.
Akira, do you want to add something?
No.
Jiamin?
I think for now I'm okay.
Okay, everyone okay? So we proceed to the next question. Okay, for the question number is the length of the core promoter, right? So is 30 plus 7. 30 if based on my understanding, the 30 is referred to from here until here. Here. Then I think uh is it plus 3 or plus 7? I think it's plus 3, right? Or
May I know why it is plus 3, plus 7? 30 is for the data box, but for the 7 is for initiator element plus 7.
wait,
Can I do?
does any okay, Annie, you try to answer?
Can I know? Is that is for transition insertion type for the
Uh, I,
for the
I
first
can't
one?
hear you clearly.
Can I know? Is that is the for the insertion element? Insert element for capital A.
Capital A, yeah, capital is for initiator element. We
I
are
think the
confused why.
sorry,
Hmm.
I think
Yes,
the
yes, yes,
capital
continue.
A, I think the capital A is for transcription start type, but the initiator element is around the transcription start site. Because A is plus 1 is the region where the transcription starts.
Yes. And between the plus one is also known as the plus one is indicate the transcription subsite. Then the downstream and upstream of the initiator element is called initiator element. Then do you all think this is supposed to be 7 or what else number?
I think it's supposed to be 7 because we don't really know the initiation type. We just assume it. If I'm right,
Is it the 7 refer to here 1, 2, 3, 4, 5, 6, 7?
yes.
If here is 7, then this is plus 1. Then this is plus 1, right? Then it is minus 1. Is it minus 1?
Yes, I know.
Min- minus, minus 1, then minus 2, minus 3. I think it should plus 3. Is it?
Yes, I agree with the
So
means can be G until G, GCT.
Jamin, can you repeat again because it's quite a little bit lagging.
You hear me?
Okay, can now can more better.
Okay. Okay.
Hello, can you hear me?
Yes.
I suddenly think we should. Okay, is it Jamin? Okay. Before that, does anyone want to add something? I I suddenly changed my what I say just now. I want to change. I think it's the 30 plus 4 here 4. Is it make sense or getting weird? Danny, are you okay? Okay, here we can see the chat box. Jiaming type. Does no any means initiated element is between G, C, D, A, B, G, G? Then no any replies Jiaming. I mean transcription in distinction side between that sequence. Is it Jiaming here or suddenly? Never mind, we wait for her. Hello, Jenny.
Hello?
Okay, can hear clearly?
Okay. Okay.
Mm. Mhm.
Oh, sorry for just now.
Okay, never mind.
I want to ask because before I quit this meeting, I heard that the mentioned it should be 30 plus 4 until so it's 34, right?
I think it's 30 plus 4.
Okay. So is there any possibility that the initiator element is until plus 1? So the answer is 30 plus 1 equal to 31. Because based on our standing, we all know that initiator element is near transcription start site. So it is around transcription start site. The specific region we can't really determine. So is there any possibility other than 34, maybe like 31, 32, 33, or even 29?
I try to answer. If based on my understanding, I think the initiator element can like can also exist in the upstream of the transcription start site or just at the downstream of the transcription start site. I think it's got different organism have it not different organism like different what different species. I think. Mm. Does anyone want to add?
I think it's quite possible to the initiator element for at the C or D site because we don't really know about the initiator element, what the position like.
So the 34 is one of the possibility answer. Is it true?
I think the possible answer. Oh wait. Is it mean got many possible answer? Because we're not
Ah,
really sure the sequence of the initiator element, right?
yes, I think that's the answer because we only can predict because we based on the GNA sequence given, we can predict that the coding region is 34. But I think that there is other possible answers because the initiator element is just within the range of transcription start site. So I think 34 is acceptable. But other than 34, maybe they still have other answer. Maybe
So
37 also accepted. So we not really know about this because we don't know the specific region of initiate, specific location of initiator element.
here got many possible answer. Before okay, that's all for our discussion. Before we want to end our discussion, does anyone want to add something or share something? Haniza, Rani, Fakira, or Jami?
Oh, about the coding sequence, I just realized that in that figure got mentioned about the coding sequence. Can you slide yeah, there. The blue
Oh,
color
this.
coding sequence.
Mm,
So it does not necessarily start from the transcription.
Okay.
I got one question. Is it database is always start from PA, like PA? TATAAT. Can it change maybe TATAAT or TATAAA? Maybe at the end of the data box, there is some changes with the best.
You mean the data box is like got TATA, then the subsequent nucleotide will be varies?
Now what I mean is it data box, the sequence is always TATAAT, or maybe they can be TATAAA.
I think they can be TATAAA based on because the data box is a consensus sequence. It depends on the high percentage which the nucleotide exit at that particular area. So maybe can be TATAAA or TATAAP.
Okay.
Does anyone want to add something? Fakira, do you want to add something?
No.
Haniza?
No.
No, Aini?
For me,
Mm. Jamin?
I think no for me.
Okay. Okay. That's all for our discussion for the transcription. Thank you. Bye bye.
Thank you.
Thank you.